my plants, and I just don't have enough velocity to get it to the plants over there.
Well, I don't have a spare hose, but I do think I know a way you can increase your velocity.
Really? How?
Well, I've been taking a class of bees with the most incredible professor, Dr. Zhang, and he's taught me everything I need to know about this kind of situation. I think he said it had something to do with the way the diameter affects your velocity coming out of the hose. Anyways, come with me to the engineering building, we'll figure it out. All right, let me explain. So, we know, due to some research we've done, that the Lake Charles volumetric flow of water is going to come out about 10 GPM. If we convert that over to feet cubed, we'll get 1.337 feet cubed per minute coming out of our water hose. Right now, we're using a 3/4 inch hose, so we have that written here, and that's in 3/4 inches. If we multiply that over by using a conversion factor for feet, we'll get 1/16 of a foot for our diameter right now. So if we take that diameter and we put it into an area calculation, we can find the area of our cross section by multiplying pi times our diameter squared over 4. And once we've done that, that comes out to 0.003 about feet squared. We can take our volumetric flow rate, which we calculated up here, and that's in feet cubed per minute. That's our Q. If we take that and we divide it by the area we've just found, we will get about 435.8-ish feet per minute. And that's our velocity. And if we convert that over to feet per second, we'll get about 7.26. We know, according to the law of conservation of mass, that our volumetric flow rate has to remain equal no matter what. We know if we take our Q, or our volumetric flow rate, we break it down, it's our velocity times our area. So that means anywhere in the hose, our velocity of one section times the area of one section has to be equal to the velocity of the next section times the area of the next section. All right, so here's the end of your hose, right here, right? Your diameter is gonna stretch right here. And right now, your diameter is 3/4 of an inch. But if you take your thumb and you just cover about half, your new diameter is gonna be just about half. It's gonna be a lot smaller. So if we come over here, we'll take our 3/4 of an inch, and we'll divide it by 2, and we'll get 3/8 of an inch instead of 3/4 of an inch for our diameter. We're going to convert that over to feet. Once we've converted that to feet, we can go ahead and calculate our new area coming out of the nozzle. We're going to do that using the same formula that we did in the last calculation, pi times our new diameter squared over 4. We'll get 0.000767 feet squared as our cross-sectional area. If you look here, this 1.337 is the same Q we used in our last calculation. And that's following the law of conservation of mass. So we're going to take our same Q divided by our new cross-sectional area. We're going to come up with our new velocity. Now this velocity is in feet per minute. We want it in feet per second. So we're going to divide it by 60, and we're going to come out with our new velocity much higher of 29 feet per second. All right, well, let's go ahead and try it. All right, have a great day.